everybody to this Friday, I believe. Why do I always have to think about the day? Pretty sure it's Friday. Let's go with that. Maybe I should just not say the day, and then there's no risk. Let me just open up our book here and we'll get started. Okay. There we go. All right. Zoom, 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 zoom. There. Okay. Yesterday, we talked about going back to basics and how we would introduce addition and subtraction with integers as a very first attempt, the very first time. What are my options for giving the student, maybe grade 1-ish, a systematic way to figure out how to add and subtract two integers? Now, in that first exposure, admittedly, you might restrict it to just positive integers, but really the positive and negative integers are all just points on the number line. They're equally important and it doesn't really matter. So we just look at all the integers. And we did the number line model as one way to explain and give them a way to figure out how to add two numbers, how to subtract two numbers. We want to have some choices, want to have an alternative, and the other main option is the chip model. That is next. Some people like the chip model, some people like the number line model. It really doesn't matter. It's good to know your options so that if you work with a student and the number line just doesn't seem to be something that they can get on top of some reason, you know that you have an option, try something else. You're not going to force that issue and make it unpleasant. So the chip model is an alternative. Maybe there are more, but these are the main two ones we'll discuss. The benefit of the chip model is I'm going to have actual chips or actual objects that you and the student can interact with. As many as you want. We'll have positive chips, and let's give them some color. Maybe you color them blue. Maybe they're blue, right? Now, we are just illustrating this and drawing pictures, but remember, throughout, you would have actual chips to move around, to give and to take and to do stuff with. And many kids respond to that very nicely, whereas the number line is a little bit more abstract, I suppose. Yeah, you can draw it and you can walk around on it, but it's not like things you can count off. And then we also have negative chips. Let's make them red. I should probably put the negative sign on them, right? I can do it up top. Negative chips, red, bad. Negative chips. So with colors, you can more obviously distinguish between these two, but of course we don't need to. We just need to know that there are two types, and you have infinitely many of them, as many as you need. So just like before, we're going to do it by example and then look back and see what was the common thread, how does the chip model work, but by example is perfectly fine. So I have to start out, whenever I use the chip model, I have to make it known to myself, to whoever grades a test, to little Timmy, to whatever the situation is, which chips are positive, which chips are negative. They won't necessarily have a plus sign on them. They might actually not. Let's actually get rid of that plus sign. That might be a better thing to do, actually. There we go. Some chips are positive, some chips are negative. Now let's just write that out in words then. So we'll have our positive chips and we'll have our negative chips. So, for example, if I want to represent 3 with in chip form, I would have, that's not a chip, that's a chip with a bite out of it. I would have 3 positive chips on the table. Now I'm just amusing myself by coloring them, but I'll try and not waste your time too much. So I represent 3 things. Well, then you put 3 chips, 3 positive chips on the table. So the blue chips are going to represent things that I have. Right? I possessed 3 things. If, for example, I represent the quantity -2, well, the negative integers are now a little bit more directly representing debt, something that I'm owing. So even though I want to visualize that with 2 negative chips, what they intuitively represent is perhaps a little bit different. This then simply acts as a reminder in a way that I'm owing 2 chips to someone. Now, I like to think of it sort of in the old days, long, long ago, when people didn't have a lot. Maybe I was a chicken farmer, and my neighbor did me a favor, and I owe them 2 chickens. -2 represents the number of chickens. Let's suppose I have no chickens right now. He did me a favor. I agreed to owe him 2 chickens. How many chickens do I currently have? I have -2 chickens because I have nothing and I still need to give him 2 chickens. So I'm 2 chickens in debt. That's how I'd like to intuitively think about the negative integers, okay, representing debt, and the positive integers represent what I actually have for myself. It's mine. I have 3 chickens. Okay. That helps me moving forward to think about what I have and what I owe. So let's look at exercise. I guess it'll be 12.2. Let me triple check here. Nope, that's a problem. Chip model, chip model, chip model. There we go. Chip model. Might be the same ones that we're working with. Doesn't really matter. I just want some variety to see different things. Are there little tricky things in the chip model that I need to be aware of? And how does it work? Well, in the very, very simplest case of adding 2 positive integers, I now am going to look at this first number as what I start with, or what I have at the beginning before things happen. So I'll maybe write out here what I have is 3 positive chips. I have 3 things. I'm not owing it. I have them. So I want to see them. I have 3 chickens running around on my little farm. Then We don't know the reason. I am gaining, or let's just keep the word adding, right? I'm adding 2 more chickens. So then, actually, I'm going to use a different word. Maybe little Timmy doesn't like add. So I'm going to put this together with 2 more chickens. These are very circular shaped blue chickens, but I assure you they are healthy. Now I have more chickens. So now I end with more chickens. 1, 2, 3, 4, 5 by simply merging them together and not distinguishing between what I had and what I gain. Excuse me. That is how many chickens I have. Now this is of course going to be much more effective when you put tokens or chips or whatever objects on the table and just merge them, and it's much more interactive than we can illustrate over here. The one downside to having a virtual classroom, I suppose. Let's just all make them blue. So I want to write this out in a way that is as clear as possible in how the process starts and ends with an amount. Okay? So don't be lazy. Draw some tokens, give them colors, do something to make it clear. This is what I start with, then I'm putting more with it, and I end with just a merger of these tokens. Okay, so that is the very, very simplest case. And of course, one I would start with. See some things, put more with them, and I end up with a collection. However, I'm just trying to think what is the best. Let's just do a 1b and make it 3 plus -1. Remember, there are no mathematical shortcuts here. So this means I start with 3 chickens. Now you could put that into context for little Timmy. You could maybe start with 3 pieces of candy or something, right? Then I am adding to that. I am adding 1 amount of debt. So something happened, and you can tell a story, you can be creative, you can do a lot of things here. I have 3 things. I'm going to go with the farmer and the chickens because it works for me. But of course, make it more relevant to little Timmy when you're sitting in front of him, right? I have 3 chickens on my farm. Something happens, and I owe someone a chicken. So that's debt that is being added to me. I have gained some debt. It is a gaining of debt. I have gained something. So you can call this gain or add or whatever word you want to use. Just intuitively, if I had 3 chickens and now I have a debt of 1 chicken, how many chickens do I really have? Obviously, only 2 chickens. So it's not a big leap to make the simplification that the debt will cancel with 1 of my chickens. A positive and a negative chip will cancel each other. And what I am left with, or let's say end with, will be 2, whatever it is, chickens. I had 3 chickens. I gained a debt of 1 chicken. For some reason, someone did me a favor. I promised them a chicken, whatever the reason may be. What I'm left with, when I clean everything up, the net result is 2 chickens. Okay. So the key in the chip model is that a positive and negative object, positive and negative chip, will cancel each other out. And I can simplify the collection of things I have by using that. Oops, we are out of space. Let's go to number 2. So it's just a different approach to tell a story and make the calculation more relatable. I guess we did never write our answers, right? We should probably write here 2. And the obvious 5. It's just, how do I tell a story to give them some context, some attachment to this, some intuitive connection? Number line is one thing, that I'm walking on a path back and forth according to some rules. That doesn't work. Get some objects. I have 1 chicken. A very round, healthy chicken. Now, I guess someone did me a huge favor. And I am gaining or adding to my chickens 4, a debt of 4 chickens. Something happened. Tell the story. Be creative. I did someone a big favor. No, so they did me a big favor, rather. And I felt compelled to promise them 4 chickens. Oops. Maybe it was worth it. Maybe it was worth it. So what do I end with? Well, it's just a matter of canceling a positive and a negative pair. But sadly, I am left with some debt. Which makes total sense, right? I had 1 chicken on my farm. Someone did me a humongous favor. Maybe they saved my life. I was going to fall into the river and they caught me or something. And I said, I will give you 4 chickens. Thank you. Well, I have 1 on my farm, so I can get rid of 1 of those debts, but I still have 3 that I owe him or her or them or whatever. Okay, so it intuitively makes sense to me if you tell the story in a way that is relatable. Okay. So then, my answer here is, of course, we knew -3. But how I get this -3, how I perform this calculation to get the answer is completely different on an intuitive, natural, basic level than what I did with the number line. And some can argue, some do argue, that the number line is very abstract. Why do they look the way they do and step the way they do? And it feels weird. Well, don't decide for little Timmy. Let him decide. If he feels the number line is weird and he's not connecting with it, then swap. But chances are he's not going to react like that. In my experience, the number line is perfectly natural for most kids. But you have an option. Maybe them seeing things, tokens, moving tokens around, adding to their collection, taking away. Maybe that this is a more enjoyable experience for them. You want to create that positivity that, oh, I can find the answer. Yeah, let me move some tokens. Tell a story. There's a lot you can do. Math does not have to be sort of sterile and cold and abstract at all. Let us continue with some more examples. Now let's go to subtraction. 3 minus 5. Now, let me just emphasize here, so it's on record, that you are not supposed to here say, oh, 1 plus -4, I know, is 1 minus 4 is -3. That is not what we're doing here. You will get 0. I will, if anyone does this and then complains about it, I will refer to the timestamp in this video where I warned you. This is not the point. It says use the chip model and explain how That is used to find this answer. There is no mathematical shortcuts, which are true, but that's not the point here. Think as basic as you possibly can. So my first number is representing how much I start with. And it's a positive number in this case. So I have 3 chickens running around on my farm. They don't look very running, but that's okay. Now we are subtracting. So the addition and subtraction operation is handled very differently from the number line model, and it's as intuitive as possible. It is simply a take away action. So now here's the, let me just make this simple for now. Let's just suppose we are subtracting 1. Let's call this 3a. I'm changing them on the fly as I want to because I can. When it comes to take away, this is going to come up again in fractions. As a personal rule for myself to make things as clear as possible, I don't draw another token here. It confuses to me if I do this. I've seen the confusion. If I do this, chances are at some point in your career, you're going to get someone that thinks that they have 4 things. That's not at all what's happening. When it comes to subtraction, I see this more as an instruction. Why is it blue? I don't know. This is more an instruction for what to do with what I have. And the instruction is take away 1. Write it in words. Take away 1 chicken. 1 positive chip. Then I go and do that. You're gone. Take it away. It's gone. And then I say I'm left with, obviously, you can see it on the table. If you act this out, 2 positive chips. In my personal experience, acting out the takeaway instead of representing it makes a big difference. That you never on the table. So let's suppose if you are acting this out, you would put down your 3 chips and you would tell the student to remove 1 chip. They would physically take it away and see the 2 that are left. On paper, I want to be as close as that as possible. So I'm not going to draw an extra chip over here, making it look as if there are 4. Because there will never be 4 chips on the table if I act this out, if I tell the story. There shouldn't be 4 chips on the table here either. But I'm trying to represent on the page as closely as possible what is happening in those acting out, steps. So I like to represent the act of taking away and not list the second number. This number is never something I have separate from my initial collection. So this was 3a, right? I lost the a. If I now go to the actual 3 in the book, it is 3 minus 5. Oops, we didn't write the answer here, did we? Obviously 2. Well, the answer is important, but it's hardly challenging for us. So I have my 3 chickens running around on my farm. Represented by blue because at the start of this question, at the start of any question, remember you have to make it super clear what is positive and what is negative. And we did that over here, right? You have to do that. Or I don't know, maybe you want blue to be a negative. If you don't tell me, I have to guess. And if I guess, then I could guess wrong. I don't know. It has to be clear. Okay. So now my instructions are to take away 5. Oops, I'm not going to write the 5 there. I could take away according to the instructions here. Now the pickle is, maybe there's a huge tax on chickens or something. And the government comes and says, we're coming to take 5 chickens. Like, I don't have 5 chickens. I don't have it. Visibly, you can verify it is not there. But they're coming. They're coming to take 5. So then I go to my neighbor and say, look, can you help me out? I need to get ready for the tax man that's going to take 5 chickens. The neighbor says, okay, here, have a chicken. But remember, you're going to owe me 1. And have another chicken, but you're going to owe me 1. So now what I really have, I don't really have 5 chickens. I'm able to see 5 chickens running around, but I also have a debt to my neighbor to get to the point of seeing the 5 chickens. So I'm still at 3 chickens, really, when I do all the cancellation and clean up and settling of my debt. However, now I'm able to see 5 chickens and the taxman can come and remove them. So now he comes, all of them are taken away. What am I left with? I'm left with owing my neighbor 2 chickens. Though he has sympathy for my situation, I still owe him 2 chickens. Figure it out. That is what I'm left with. So there's a lot of creativity, there's a lot of story you can tell here, making it much more relatable. And I try and do that. I sort of come from the historical number systems, and I'm still thinking about them. And because these basic numbers and basic calculations originated in a more basic, simple, I guess, civilization. So I think of farming. I don't know why chickens. Easy to move chickens around, I guess. All right. So a lot you can do here to be creative, tell a story. The issue here is that if my instructions are to take something away, that means I have to see that amount to follow the instructions. And if I don't, I can bring in these positive negative pairs to get what I need to see. Let's see what our next one is. And then we'll see if anything is maybe missing in the variety that we need to see. Okay, number 4. 4. Oh, I keep forgetting to write the answer. This is terrible. -2, obviously, right? 4 minus -2. Okay, so I have 4 chickens on my farm. The first number tells me what I am starting with. I'm starting with 4 chickens on my farm. Remember, I'm following the instructions exactly the way they are written out. I am not simplifying this first. Then the instructions are clearly to take away. So this is what I start with. This is now the instruction. And I guess the the operation and the second number is the instruction, really. So I need to take away this guy. I need to take away 2 red chips. I don't want to draw the red chips. That's going to be confusing. I need to, however, follow the instructions, which means I need to see the things I need to take away before I can actually remove them. If you put 4 blue chips on the table in front of little Timmy, and you tell him, okay, Timmy, now take your hand and remove 2 red chips. What is he going to tell you? He's going to tell you, I can't do it. Why? Because I don't see 2 red chips. So I need to sort of alter the appearance of what I have in order to follow the instructions. Alternatively, you can tell a more creative story and say, I have 4 chickens on my farm. The government comes around and says, this is your lucky day. We're going to forgive debt for everyone. We're going to forgive a debt of 2 chickens for everyone. For everyone, we'll remove 2 chickens of debt. Now I'm thinking, oh, well, this is my lucky day. However, I currently don't have debt. Now, let's think about this. The government's coming, and they're removing 2 debt. So I'm going to go to my neighbor and say, hey, give me some chickens, and I'll owe you. I'm trying to create some debt. Can I have 2 chickens? And I will, of course, owe you 2 chickens then, right? The neighbor says, sure, if you're going to pay me back, I'm good. It's all good. Yeah. Nothing lost, really. It's just temporary. Sure, you owe me 2 chickens, right? Now the government comes around the next day or whatever and says, well, you don't have to worry about how. We're going to settle your debt for you of 2 chickens. We're removing that debt. So then I am left with 6 chickens. And I don't have to worry about my debt anymore. So I was a little bit crafty, knowing that 2 debt will be removed. I can go and create that debt and then lose it, and then I have more. See the nice stories you can tell? The chip model in many ways is more fun because you can tell the story in a relatable way and try and figure out, well, how can I tell a story that's going to relate to this student I'm working with or whoever's sitting in front of you? Or for myself, how can I tell a story that makes the most sense to me? And of course, I know the answer is going to be 6. Notice again that in no way did I ever make it 4 add 2. But you can argue and look at this after you've done this for a while, right? Just like we did for the number line. You can say, if I start with 4, which is what I did, and I want to end with 6, yes, again, there are 2 ways to do it. There is the way of directly just bringing 2 in, adding to it, that'll be the plus version. Or there is this taking away of 2 negative chips that also results in 6. So yes, just like for the number line, there are 2 sides, and you can sort of guide that exploration with the student to eventually lead them to the conclusion, casually speaking, 2 negatives make a positive. But at the beginning, in the chip model itself, there is no such thing. There is no mathematical simplification of the calculation first. So I am not allowed to do that. You do that, you get 0, because that's not what the question is asking. Right. So come up with a way to sort of illustrate this and tell a story and have some fun with it. because the more fun you have with it, the more fun your student's going to have with it, and everyone's going to feel better. And when you feel better about something, it's easier. And remember that these things are not easy to do when you see them for the first time and when you're very young. So getting some context, some story, something more around it, making it more colorful and interesting goes a really long way.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.